Welcome back to the Power Exchange, where we explore the technologies and expertise shaping the future of energy in the Middle East. I'm Noura Abdelmoneim, and today we're tackling a topic that's absolutely critical to the energy transition, but often misunderstood: pumped hydro storage. As renewables continue to grow, one question becomes central. How do we store energy at scale and ensure reliability when the sun isn't shining or the wind isn't blowing? That's where pumped hydro storage comes in. Joining me is Yves-Laurent Beck, Hydro Project Manager in the Middle East. Yves-Laurent works on large-scale hydropower and storage projects, helping countries integrate more renewables while keeping power systems stable, flexible, and resilient. Hello, Yves-Laurent.
Hello, Noura. Thank you to invite me to speak.
Let's start with the basics. For people who may not be familiar with it, what is pumped hydro storage and how does it work?
Pumped hydro storage is an hydropower. It's a giant battery. We are using two reservoirs, one upper reservoir and one lower reservoir. And we are pumping up the water from the lower reservoir to the upper reservoir when we have an exceed of electricity. So we use this electricity to pump the water, and we are turbining the water from the upper reservoir to the lower reservoir when we have a need of electricity. And the global round-trip efficiency of full cycle of pumping plus turbining is around 80%.
Hydropower is a mature technology worldwide. What expertise does EDF have, or experience does EDF have in hydropower and more specifically in pumped hydro storage?
So EDF and EDF Hydro, with a branch of hydropower in EDF, is quite wide. In France, we have the main operator of hydropower, and we operate around more than 600 large dams and more than 400 hydropower plants. And we have our own engineering, and we are developing several projects worldwide. So in pumped hydro storage, EDF is an operator of 5 gigawatts of pumped hydro storage in France. We are developing several projects, and our engineering involved in more than 40 gigawatts of pumped hydro storage projects worldwide.
As solar and wind capacity increases, grid stability becomes more complex. So why is pumped hydro storage such a key solution for integrating large volumes of renewables?
In fact, in Middle East, typically we have a lot of solar, and solar PV are producing some electricity during the day, and we have a need of electricity during the night. So in fact, the main issue is to switch the electricity from the day to the night. And in fact, pumped hydro storage can transfer this amount of electricity, a huge amount of electricity from the day to the night. And in pumped hydro storage, in fact, you can deliver some what we call the ancillary services, who are the services to stabilize the frequency and the voltage of the network.
When people think of the Middle East, they don't really think of hydropower. So why does pumped hydro storage still make sense for this region?
For pumped hydro storage, we need three main components. First one, we need the need of flexibility in the network. And in Middle East, we have a rise of solar PV and renewable energy, and they need to have this flexibility. The second thing is we need some mountain, some elevation. And in fact, we have some mountain in Middle East, for example, in KSA or in UAE or in Oman, you have a lot of mountain. And the third component is the need of water. So, of course, we are in an arid region. We don't have a lot of water. However, in the mountain region, you have some flood protection dam and existing reservoir. And we can use this water for the pumped hydro storage. We are not consuming some water in pumped hydro storage. It's just a move of a volume of water during, for example, a day and to the night. So in fact, we don't consume it. So a pumped hydro storage can work as a closed loop configuration.
We can see that the battery energy storage system technology has now reached maturity at utility scale, and the costs have decreased significantly. So what is the positioning of hydro pumped storages in respect to that?
It's two different technologies. They are complementary. The battery can give you a fast response, and they are scalable, and you can distribute the battery across the national grid. And the PHS is very site-specific, but you can store a massive volume of energy. We are speaking about several tens of gigawatt-hour of storage of energy. Pumped hydro storage has a specificity to have around 70% of their cost who staying in the country.
Pumped hydro projects are large and long-term infrastructure assets. From your experience, what are the main steps and challenges in developing a pumped hydro storage plant project?
I like to say in hydropower, the project lifetime is around 100 years. And the main challenge is the construction lifetime and the development lifetime, because we are building it in few years and we need several years for building and developing. But it's a good investment for the future and for the sovereignty of the country.
Before we wrap up, what message would you share with engineers or young professionals who want to work in a large-scale energy infrastructure like pumped hydro?
So pumped hydro storage is a very mature technology, or rather it's a future technology. It's a real passion to work on a hydropower project, and the scale of the projects are incredible, and you are working in green energy.
Thank you so much, Yves-Laurent, for being with us today.
Thank you.
Pumped hydro storage is such a cornerstone of reliable, low-carbon energy systems. Today's conversation reminds us that the energy transition isn't just about generating clean power, it's also about storing it, managing it, and delivering it when it's needed most. This has been The Power Exchange. Thank you for listening, and join us next time as we continue exploring the people and technologies shaping the future of energy in the Middle East.